Hi there, today we're going to continue looking at tangent ratios and finding sides. Here is our first example. Find the length of the side. Give your answer correct to three significant figures. We have a large triangle, and inside the large triangle, we have a green smaller triangle and a pink triangle. The green triangle has an angle of 30 degrees and a side length of x. The pink triangle has an angle of 25 degrees and a side length of 8 meters. We want to find x, which is in the green triangle. To do this, we need to find the vertical side that is shared between the green and the pink triangle. Let's label this side length y. To find y, we need to use the tan ratio for the pink triangle. The tan ratio is tan theta is equal to the opposite side divided by the adjacent side. Theta in the pink triangle is 25 degrees. So we have tan 25 degrees equals to the opposite side. The opposite side of 25 is y. The adjacent side to 25 degrees is 8 meters. To remove 8 in the denominator, we'll multiply both sides by 8. We will then have 8 tan 25 degrees is equal to y. We can evaluate this on our calculator to get approximately 3.73. However, I'm going to leave it as it is. Now that we have the side length y, we can use the tan ratio for the green triangle. Again, tan theta is equal to the opposite side divided by the adjacent side. Theta in the green triangle is 30 degrees. The opposite side of 30 degrees will be y. The adjacent side is x. We already found out what y is, so let's substitute for y. Substitute y is equal to 8 tan 25 degrees. We need to move the x away from the denominator, so we'll multiply both sides by x. We will then have x tan 30 degrees equals to 8 tan 25 degrees. We want to have x by itself, so we'll move the tan 30 degrees away by dividing both sides by tan 30 degrees. We'll then have x is equal to 8 tan 25 degrees divided by tan 30 degrees. On the calculator, this gives 6.4613. Therefore, x is equal to 6.46, correct to three significant figures. Here is our next example. Find the length of the side. Give your answer correct to three significant figures. Here we have a large triangle with a smaller blue triangle and a purple triangle inside. We have a side length of x on the purple triangle and 20 meters on the blue triangle, and the angles of 10, 15, and 90 degrees. First, we need to find the side opposite 15 degrees. We'll call this side Z. We'll use the tan ratio for the blue triangle. So we'll have tan theta is equal to the opposite side divided by the adjacent side. In the blue triangle, theta is 15 degrees. So we have tan 15 degrees is equal to the opposite side, which is Z, divided by the adjacent side, which is 20. To remove 20 from the denominator, we'll multiply both sides by 20. We'll then have 20 tan 15 degrees equals to Z. Again, we'll leave that as it is. If you evaluate it now on the calculator, you may experience rounding problems later. Take a look at the larger triangle. We're going to apply the tan ratio. So we have tan theta is equal to the opposite side divided by the adjacent side. Theta in the larger triangle is going to be 10 plus 15. The opposite side is going to be x plus z, and the adjacent side is going to be 20. 10 plus 15 gives us 25. Substitute z for 20, tan, 15. This is from the previous part. Okay. To remove 20 from the denominator, we'll multiply both sides by 20. We'll then have 20 tan 25 degrees is equal to x plus 20 tan 15. We need to move the 20, 10, 15 away by subtracting both sides by 20, 10, 15. We'll then have x is equal to 20, 10, 25, subtract 20, 10, 15. This gives us x is equal to 3.967. This will be 3.97, correct to three significant figures. Here is our last example. The angle of depression from a window 5 meters above ground level to a bird on the ground is 40 degrees. Find the distance between the bird and the building. We first need a diagram. In our diagram, we have that the bird is x meters away from the bottom of the building, and the window is 5 meters above ground level. The angle of depression is 40 degrees. What the angle of depression is the angle formed from the horizontal looking down. Using our knowledge of alternate angles, we actually have 40 degrees appearing elsewhere as well. 40 degrees also lies within our triangle. So we have 40 degrees as our angle of elevation as well from the bird looking up. To start our question, we need to write the tan ratio, which is tan theta is equal to the opposite side divided by the adjacent side. In this triangle, theta will be 40 degrees. The opposite side of theta is 5 meters, and the adjacent side was going to be x. To remove x in the denominator, we'll multiply both sides by x. We will then have x tan 40 degrees equals to 5. To get x by itself, we'll remove tan 40 degrees by dividing tan 40 degrees away. Make sure you do it to both sides so that the equation remains balanced. We'll then have x is equal to 5 tan 40 degrees. On the calculator, this gives 5.958. Our answer to three significant figures will be 5.96 meters.